Hey guys, how are you? So we're going to start lesson 6 here. Lesson 6 is actually moving into a new skill. It will use parts of what we've already learned about graphing some points and everything, but it's basically we're moving a little bit closer towards graphs and graphing, and then our next base skill, which will be line plots. But anyway, so today's lesson is tables and kinds of graphs. So by the end of this lesson, you should understand how a table is used to create a graph, and then the different kinds of graphs that you might see as you go through your math work, and then why do I choose to use one type of graph over another graph. So when I look at a data table, why might I choose to make a line graph instead of a line plot? Or why would I choose to make a bar graph instead of a circle graph? So those types of things. So I'll go through and I'll explain each of those things as we go through this lesson. Please make sure you watch the entire lesson so that you fully understand this, so that you're ready for the next lesson that's coming later. Okay, so biggest thing is all graphs start from some type of data table. Data gets recorded into a table, and then that's turned into a graph so that you can see the relationships and connections more easily. Okay, so basically how I would have explained this in class, and I would have said this over and over, but the whole purpose of a graph is to show a pretty little picture of our data, because when we just look at a table, it just looks kind of like blah and boring, and you don't really see how different parts of it are connected. But whenever you put that into a pretty little picture or visual with some color and everything, that data just starts to pop, and you can see so many more connections and relationships. Okay, so our first type of graph is a bar graph, and it's called a bar graph because when you do the representation of it, you have bars of information. Now this one, the bars are going straight up from bottom to top. You can see bar graphs where the bars actually go, instead of going up, the data will be plotted over here, and the bars will actually go from left to right also. It's just a sideways bar graph. Most of the time you're going to see them set up just like this one. So let's look at this. So here's our data table on the left, and this bar graph is all about Michael's test scores. How do I know that? Because the data table has a title, and then that title gets related over to the bar graph at the top. So Michael's test scores. So there's two different bits of information. His tests, there were 5 tests, and then all of his scores for each of those tests. So then the top becomes the X and the bottom becomes the Y. So over here on the X axis, we have the 5 different tests labeled. We have our label that says, hey, these numbers represent tests. And then over here on the left, we have a scale from 0 to 100, our label of scores, and then it's jumping, or it's counting by 20. We'll talk about the vocab for all that yesterday. But anyway, why would we choose a bar graph to show Michael's test scores? Well, in this case, this bar graph is being used to compare data. And bar graphs, that's their one and only purpose, is to compare things. So because Michael's test scores are in a bar graph, we can compare, and we can say, ooh, his second test, he had his lowest score compared to all the rest of the tests. His 5th test was the highest score compared to everything else. So we can see the lowest, the highest, and everything in between, and we can do comparisons here and just looking at that. So some other types of graphs that could be graphed out as a bar graph, because they're used to compare data, is like if I did a survey or information about favorite types of snacks. So on the bottom here, I might have like popcorn, chips, pretzels, I don't know, gummy bears, I don't know, but different types of snacks, and then the numbers would represent, and we could compare, oh, this snack is the least, this snack is the most. We could say, oh, maybe there's 2 snacks that are tied, but it's used to compare information. So that's the whole purpose of a bar graph, to compare data. And this one's black and white, but all these different bars could be different colors and everything. There also could be something called a double bar graph, where you might say, oh, this is what the girls chose, and they might be a purple color, and this is what the boys chose, and they might be a blue. So like, let's say this was chips for the snack one, and we could have our girls number and then our boys number right next to each other, and then we'd have pretzels, girls number, boys number. That's called a double bar graph. Okay, so let's look at our next type of graph. This is a circle graph. Some people call it a pie chart. Some people call it a pie graph, but its technical name is a circle graph. And circle graphs are used to show parts of a whole. So the circle is the whole thing, and then it's broken down into little pieces, kind of like fractions. And they show us how something is used or spent. So examples would be how time is spent or how money is spent. This one is, and we can look at our title on the graph and on the data table, is how math time, 60 minutes worth of math time is being spent. So for group work, they have 40 minutes and homework is 20 minutes. Now, where did that come from? Well, because in the graph here, I have 60 minutes and it's broken down into 6 sections. So each section has to represent 10 minutes. So 10, 20, 30, 40, 50, 60 minutes. So because there's 4 sections of group work, that's 10, 20, 30, 40 minutes of group work, and homework is 2 sections, so that's 10, 20, so that's 20 minutes. So it's showing how one whole hour or 60 minutes is broken down into little pieces, and each piece is equal of 10 minutes per thing. So you could do this with money too. You could say, oh, I have $20, and then break it down into fractional pieces and say, this is how I spent my $20, $5 on a new game, $10 on a DVD or something like that. Okay, and you can show how it's broken down. But circle graphs are used to break down a whole thing into its little pieces. Okay, our next graph is a line graph, and line graph's whole purpose is to show change over time. So because it's change over time, the x-axis or the bottom is always going to be in some type of time. So in this case, it's years. It could be months, it could be days, it could be hours, minutes, seconds, I guess you could go decades, things like that, but it has to be some type of time. And then it's a line graph because you plot points for the X and the Y, and then you connect them with a line. So over here, this is the XYZ Toy Company, and it's showing how much toys were sold in the millions of dollars. So in 1992, their sales were 120 million. And then you notice, so showing change over time, the next year, something must happen with their company because their sales went down horribly to 60 million that year. So they dropped half of their sales from one year to the next. But then over time, things started to increase and get better for this toy company. Maybe they came up with a brand new toy that everyone really loved and people just went crazy over it and had to buy it, but they start increasing. So you can see you change over time. Oh, business not doing good. Oh, business doing a little better. Oh, it's getting even better. And oh, it's getting better. So change over time is what we have our line graph. And this is not showing a relationship because it's not a perfect diagonal. It's now dipping and peaking. Okay, so it's going up and down, and that's showing that change over time. Okay, our 5th type of graph is a line plot, and we're going to spend a lot of our 5th grade lessons over the next couple weeks on line plots, but line plots show data along a number line. So you just have a number line on this one. You don't have an X and a Y. You just basically have an X, and it's a number line. Line plots also compare data just like a bar graph, but it's being represented using these X's. So each X represents a number, one number in a data set. Okay, so in this case, what was being collected was the height of 2nd graders in inches. So then down the left column or the X column, we have all of our numbers that are going to be on our number line. So 40, 41, 42 going the whole way through 49. And then next to each one in a line plot data table, the data is usually collected by tally marks. So we don't see numbers, we see tallies. So for 40, there were 2 students that were 40 inches. And then 41 only has 1, 42 has 1, 43 has no students that are 43 inches. And then 44 inches is 5 students. So all these tallies then get transferred over onto your line plot as X's. So there's 2 at 40, 1 at 41, 1 at 42, none at 43. And then you can go in here and you can compare and say, ooh, the greatest amount of students were 44 inches tall. Or the least amount of students that had a height was 43 because 0 students were 43 inches high. You can also say, oh, there were 4 students who were 42 inches or less in height. And you can say, oh, 1, 2, 3, 4, 42 inches or less is all of these guys right here. So it's really used to compare and to do a really quick representation of some data that gets stated. And we have one more graph. It's our pictograph. We don't use these very often, but a pictograph uses pictures or icons to represent data, and there's always a key. It is once again used to compare data, but it's doing it differently using pictures. So on the left here, I have kids' choices. And I got this graph from somewhere. I'm not sure why the kids were choosing automobiles and computers and electric lights and stuff like that. But you'll notice that in my numbers here in the data table, they're a little different than the pictures. Because for an automobile, it says that there's 20 kids. When I look over here at automobile, there's only 4 little tiny icons or pictures of like this little person. Well, that's because there's a key over here and it says that each little person represents 5 students. So this does show 20 because 5, 10, 15, 20. So automobiles, there were 20 kids, so I needed 4 little people to represent 20. And the computer, I have 5, 10, 15, 20, 25, 30, 35. So I have 7 little people because 7 times 5 is 35. So the numbers for a pictograph from your data table don't totally match up with what you end up with your icons because each icon doesn't just stand for one thing. It stands for whatever the key said. Now in some pictographs, you'll see an icon cut in half. Okay, so let's imagine for the television, we have 5.5 people here. Now with this one, it's kind of a little, you can't really do this with a half a person because each person stands for 5 students. And if I cut one of these guys in half, that would then end up being 2.5 people and 2.5 people. So if I cut this little guy here, what's left is worth 2.5. Well, a half of a person couldn't vote for a television. So because this is an odd number of 5 students, you can't really have a half. But if this key stood for each little person equals 4 people and I had a half person, then it would be equal to half of a person would be equal to 2. But sometimes whenever you see these, like I have another example where there's cupcakes and each cupcake is represented by 10 choices. So if I cut one in half, it stands for 5, which works, okay? Because you can say 5 cupcakes. You can't really say 2.5 people voted for something, okay? So those are our different types of graphs. Now we're going to just do a little bit of practice here. Sorry about that. Just do a little bit of practice. So I'm going to state a question and I want you to pause and think about what your answer is and then unpause to check the answer with me. Okay? So first question, which type of graph would you choose to show how much it snowed each week in January? Okay, so go ahead and pause. Okay, the answer is a line graph because it's going to show change over time. Okay, here's our second one. What type of graph would you use to compare how many people picked the different lunch options for a day? Okay, so think about the best type of graph for that and hit pause. When you have your answer, hit play. Okay, the correct answer is a bar graph. Although a line plot would work also if you're doing a really quick survey, but since we're comparing, bar graph would be our best choice. Okay, which type of graph would be the best graph to choose to show how I spent my allowance this month? Okay, so go ahead and hit pause, come back when you're ready. Okay, best choice would be circle graph, okay, because it's showing your whole allowance and then how you're breaking it down into parts. Okay, so I'm gonna skip this one. Okay. So, which graph is the most appropriate to represent the amount of money spent on the military over a period of time? So, when you're ready for your answer, come back. Okay, the answer would be a line graph because it's showing change over a period of time. Which graph would be most appropriate to show the results of a survey of how many minutes that 25 employees travel to work? Pause. Okay, the correct answer is line plot because it's a quick survey just showing the numbers. So I have a survey conducted on the length and names of students in class. What type of graph would be appropriate? Pause. And correct answer is line plot again. Okay. This table shows the kinds of pets the students have in class. What type of graph would be most appropriate? Go ahead and pause. And the correct answer would be bar graph because we're comparing information. Okay, last one. This table shows the yearly average in earnings of men and women. Which type of graph would be the most appropriate? So we have for 4 years the men's average earnings and then women's average earnings. So go ahead and pause. Okay, this will be our last question, and the correct answer would be comparing men and women and their earnings. line graph showing change over time. And this one would actually have two lines, one line for the men and one line for the women. Okay, guys, I'll talk to you another day with a new lesson.